Imagine you're getting ready for your morning commute. You walk out to your car, slide into the driver's seat, buckle your seatbelt.
Right, the usual routine.
Exactly.
Yeah.
But right there, aimed squarely at the center of your chest, is a solid, unyielding steel spear.
Oh, man.
It's bolted directly to the front axle of the car, and every single time you go for a drive, you just have to hope you don't hit anything hard enough to drive that metal pole straight through you.
Which is a terrifying mental image.
Right. But for the first 50 years of automotive history, that wasn't like some exaggerated horror movie scenario. That was just called driving your car.
It really was. I mean, historically, it's completely accurate. The steering column used to be this totally rigid, uncollapsible rod of iron and steel.
Just a literal weapon pointed right at you.
Yeah. We treat the steering wheel today as this harmless, static, unchanging interface, right?
Yeah.
But the reality of how that object ended up in your hands and how it evolved is a wildly chaotic story.
Which is exactly why we are so thrilled to welcome you to today's deep dive. Our mission today is to take this incredibly mundane object that you probably touch every single day, the steering wheel, and completely change how you look at it.
I love that goal.
We are basing today's deep dive entirely on the comprehensive Wikipedia article covering the steering wheel. And let me tell you, this is not just a story about turning tires.
No, definitely not.
It's a story of deadly dashboard spears, high-speed 19th century races across Europe, bizarre geometric shapes called Squircles, and, the relentless evolution of human-machine interaction.
It really is the ultimate physical touch point between humanity and the industrial age. I mean, it maps our entire relationship with the automobile.
And I could not ask for a better guide to help connect the dots of this automotive history than you. So let's jump right in.
Let's do it.
We have to start at the beginning. Before we had the wheel, drivers obviously still had to steer these early motorized carriages. But how are they actually doing that?
Well, you have to look to the water for the answer, but maybe not in the way you'd expect.
Wait, to the water.
Yeah, so near the start of the 18th century, large sea vessels were already widely using the classic many-spoke ship's wheel. It gave sailors massive mechanical advantage.
Sure, like a pirate ship wheel.
Exactly. But when the very first automobiles started hitting the dirt roads in the late 1800s, engineers didn't borrow from those large ships at all. They borrowed from smaller rowboats and sailboats.
Oh, really?
Yeah, they used a tiller.
Okay, let's unpack this. A tiller is essentially like a literal stick attached to a pivot point on the axle.
Yep, just a stick.
So you're driving an early car sitting on a bench, and you're just pushing and pulling a horizontal broom handle to make the wheels turn.
That's the visual, yeah.
It sounds like trying to steer a rogue high-speed lawnmower. I mean, if it's a direct one-to-one mechanical linkage, every single bump in the road is going to translate directly into that stick.
Exactly, and that was the fatal flaw. It was incredibly unstable. You have to picture the roads in the 1890s.
Probably not great.
Not at all. We aren't talking about smooth asphalt. We're talking about deeply rutted dirt paths designed for horse hooves and wooden wagon wheels.
Oh, man, yeah.
If your primitive car hit a rock or a deep rut, the front wheels would violently jerk sideways. And because of that direct one-to-one linkage you mentioned,
The tiller would just snap back.
violently whip right across the cabin. I mean, it could easily break a driver's wrist or be ripped right out of their hands.
Wow. So relying on a boat stick for a land vehicle weighing hundreds of pounds was clearly a terrible idea once speed started to increase.
Oh, definitely.
Who finally realized they needed to gear this searing down and, use an actual wheel.
The realization really came from the racing world.
Yeah.
In 1894, a man named Alfred Vacheron entered the Paris-Rouen race.
Okay.
He looked at his Panhard 4-horsepower model and just decided the tiller was a liability, so he fitted it with a circular steering wheel instead.
He figured it out himself.
Yeah, and that is widely considered one of the earliest employments of the wheel in a car. It allowed for a reduction gear, meaning he could turn the wheel a lot to move the tires a little.
Oh, that makes sense.
Right. That gave him immense leverage, far more control, and the ability to make continuous fluid adjustments without constantly fighting the road.
And I imagine the rest of the automotive world saw this massive mechanical advantage and just immediately changed course.
Well, in Europe, the pivot happened pretty quickly. By 1898, that same company, Panhard and Levasseur, made the steering wheel standard equipment on all their new cars.
Wow, just 4 years later.
Yeah, and that very same year, Arthur Constantin Krebs designed a car for the Paris-Amsterdam-Paris race and used an inclined steering wheel.
Meaning it was angled toward the driver.
Exactly. Rather than straight up and down like a bus, it provided a massive ergonomic and performance advantage.
But the American market didn't catch on quite as fast, did they?
No, they really didn't.
Because the source material mentions the American inventors Thomas B. Jeffrey and his son Charles. And in 1898, they actually developed two advanced experimental cars that featured a left-hand drive steering wheel.
Right.
So they knew the technology existed. But then, when they went to mass-produce their first Rambler cars in 1902, they completely ditched the wheel.
Yeah.
They stuck to a rear-engine layout and went right back to the tiller. They didn't switch back to the steering wheel until late 1903.
Which seems crazy in hindsight.
I have to push back here. Why on earth would you invent the superior, safer technology in 1898, know it works perfectly, and then revert to the inferior, dangerous tiller for your big mass-market launch?
What's fascinating here is how clearly this illustrates the psychology of technological adoption.
Oh.
Innovation almost always takes a backseat to familiar, conventional layouts, especially when you're trying to build a brand new consumer market.
Because they were afraid of scaring away the buyers.
Precisely. Think about it. In 1902, the American public was deeply skeptical of automobiles. They were loud, they spewed smoke, they terrified the horses.
Right, they were basically monsters to most people.
Exactly. Jeffrey was trying to sell these radical new machines to people who had spent their entire lives operating horse-drawn carriages or, riding bicycles. A tiller, in a weird way, felt familiar.
Like reins.
Yeah, it mimicked the left-to-right pull of horse reins. It was the conventional layout of the day.
That is wild.
It wasn't until a critical mass of early adopters, like those high-profile racers in Paris, proved the steering wheel concept worked undeniably better and the public saw it in action, that the American market finally demanded the change.
So it was purely a commercial safety play that kind of backfired.
Pretty much.
But once the shift happened, it was permanent. By 1904, all Ramblers had steering wheels. And interestingly, at Jeffrey's insistence, the driver's seat was moved to the left-hand side of the car during that 1903 production run.
Which was a big deal.
Huge. By 1910, most U.S. automakers were offering left-hand drive, and soon it became the permanent American standard.
Which allowed the driver to better see oncoming traffic on those two-way dirt roads.
Right. So the wheel decisively wins the battle against the tiller. But of course, once the wheel was installed, automotive designers couldn't just leave well enough alone.
Oh, never.
They had to start messing with its shape and its placement.
Oh, absolutely. The circle was really just the starting point.
Here's where it gets really interesting. Because today, looking at modern cars, it feels like a geometric arms race.
It totally does.
For over a century, the wheel was a circle, which makes perfect mechanical sense to me. It provides precise feedback through a large, continuous interface.
Right.
But now, you look at some Tesla models, and they've completely ditched the circle for a rectangular yoke with pistol grips.
The yoke is definitely controversial.
Yeah. Or you look at the new C8 Corvette, and it has this weird hybrid square circle shape that the industry actually calls a Squircle.
Gotta love the name Squircle.
It's so silly. It's got a flat bottom and a flattened top. And I have to challenge this. Doesn't a Squircle or a yoke completely defeat the ergonomic purpose?
How do you mean?
Well, driving requires a fluid, hand-over-hand turning motion, right? If you chop off the top and bottom of the wheel, you're just grabbing empty air in the middle of a U-turn. Aren't you just breaking that fluidity for the sake of looking futuristic?
It definitely seems counterintuitive, and a lot of traditionalists argue exactly what you just said, but form ultimately follows function.
Okay, so there's a practical reason.
Yeah, the shape of the steering wheel isn't just about the hand-over-hand turning motion anymore. It's heavily dictated by the physical space available in the modern car. It comes down to what automotive engineers call packaging constraints.
Meaning literally how you package a human being into the driver's seat.
Exactly. Think about the Corvette Squircle. The flat bottom exists for a very practical reason. The C8 is a very low-slung, mid-engine sports car with a high center console.
Right, very tight fit.
Right. If the wheel were a full circle, the bottom arc would physically block your thighs. The flat bottom makes it significantly easier for the driver to get their legs in and out of the car. It's about egress.
Oh, that makes sense. And the flattened top.
That's there to enhance the driver's line of sight. Modern digital gauge clusters are packed with information, and a traditional round rim would block the top half of that screen.
Okay, the Squircle makes sense for fitting into a tight sports car. But what about the Tesla yoke? If you drop the hand-over-hand motion, how do you actually park the thing?
Well, the yoke is pushing the boundaries of what a steering input looks like when cars move away from traditional mechanical steering racks. They rely more on variable steering ratios, specifically steer-by-wire systems.
Oh, meaning there's no physical steering column connecting the yoke to the wheels.
Right. In a steer-by-wire system, computers and electric motors handle the actual turning of the tires based on your input. And because it's controlled by software, the ratio can change based on your speed.
Wait, really?
Yeah. If you're on the highway going 70 miles per hour, turning the yoke 5 degrees might gently change lanes. But if you're in a parking lot going 2 miles per hour, that exact same 5-degree turn of the yoke might turn the front wheels all the way to full lock.
Oh, wow.
The software adapts, so you never actually need to cross your arms or go hand over hand, which makes the top and bottom of the steering wheel theoretically obsolete.
That is wild. It just proves that driving isn't a static interface. It's highly dynamic depending on the technology driving it.
Precisely, and we've seen this dynamic shift in shapes and sizes before, driven by engineering needs.
Like when?
Look at early Formula One cars from the 1950s. They used massive, large-diameter wooden steering wheels taken straight from road cars.
Because they needed the leverage.
Exactly. Without power steering, the drivers needed a huge lever just to get enough physical leverage to turn the car's heavy front end at high speeds.
Wow.
But as racing aerodynamics advanced into the 1960s and 70s, the cars gained lower and the cockpits became incredibly tight and compact to reduce drag. The drivers were practically lying down.
So a huge wheel wouldn't fit.
The wheels had to shrink dramatically, morphing into these small rectangular grips just to fit inside the space without hitting the driver's knees.
That's fascinating. And placement is dynamic too, right?
Yeah.
We talked about left-hand drive becoming standard in the U.S., obviously contrasting with right-hand drive in places like the U.K.
Right.
But some designers just threw the whole left versus right debate out the window, like the McLaren F1.
Oh, yeah. One of the greatest high-performance sports cars ever built.
For sure. They put the driver's seat, the pedals, and the steering wheel right in the dead center of the cabin.
Yep. You have a passenger seat slightly behind you on the left and one on the right. It's all about optimizing the car center of gravity and giving the driver perfect, symmetrical spatial awareness on a racetrack.
Okay, so playing with shapes and placement is fascinating when we're talking about sports cars and performance. But let's bring it back to everyday driving.
Okay.
And back to that terrifying spear I mentioned at the very beginning of the show. We've talked about shapes and packaging, but for decades, the placement of this rigid metal ring on top of a solid metal column posed a very real, very lethal threat to the person sitting behind it.
It's hard to overstate how dangerous it was. In a severe front-end collision, the front of the car crushes inward. Right.
Yeah.
But a solid steel steering column won't crush. So as the front axle was pushed backward by the impact, that steering column would be thrust directly into the cabin,
Oh, geez.
often impaling the driver who was, simultaneously being thrown forward by their own momentum.
And what blows my mind is the timeline here. According to the Wikipedia article, the very first collapsible steering column one, engineered with overlapping tubes designed to telescope and crush, absorbing the kinetic energy of a crash, was invented in 1934. But it was a complete market failure. It wasn't until 1968 that U.S. regulations, specifically FMVSS Standard Number 204, actually mandated that steering columns had to collapse in a crash.
It's a huge gap.
I have to push back here. If we had the brilliant mechanical technology to stop people from being impaled in 1934, why did it take a government mandate 34 years later to make it standard?
Well, this raises an important question about the automotive industry's priorities at the time, and it's a bit of a dark chapter.
I'll bet.
The harsh reality of the mid-20th century was that, historically, safety didn't sell cars. Automakers fundamentally believed that talking about safety features reminded consumers of car crashes.
Oh, which scares them away from the showroom.
Exactly.
Yeah.
They wanted to sell consumers on style, speed, chrome, and luxury. A collapsible steering column was an invisible, expensive piece of engineering that didn't look flashy on a billboard.
So they completely ignored the danger to save a few bucks and preserve their marketing vibe.
Well, there were some half measures introduced. In 1956, Ford introduced what they called a safety steering wheel.
What made it safe?
It was a deep dish design. The rim was set high above the center hub, and the spokes were designed to flex and absorb some of the energy if the driver's chest hit it.
Oh, okay.
But the underlying column itself was still completely rigid. It was essentially a Band-Aid on a spear.
That's horrifying. But there was some incredibly quirky outside-the-box engineering solutions to this before the mandate, right? Like what the French automaker Citroën was doing.
Oh, the Citroën DS. It is a masterpiece of strange avant-garde engineering.
I love the DS.
Right. So instead of a traditional wheel with 3 or 4 symmetrical spokes, the DS used a large, curved, off-center, single-spoke steering wheel.
Just one spoke.
Just one. And the entire design was engineered so that, in the event of a severe crash, the steering wheel would physically deflect and guide the driver's body off to the side, away from the solid steering column, rather than trapping them against it.
That is brilliant in a very bizarre, uniquely French way.
Oh.
But, we've talked about how that rigid column was a nightmare for crash safety. But that rigidity was also a nightmare just for everyday driving comfort, wasn't it?
Oh, absolutely.
Because without power steering, every single pothole sent a shockwave straight up that metal pole into your wrists.
Yep.
Automakers needed a way to decouple the wheel from the road, which led to a really strange musical invention. I'm looking at the banjo steering wheel.
The banjo wheel is a piece of mechanical genius.
Yeah.
Before hydraulic power steering became prevalent, though mechanical power systems were introduced around 1953 on Studebakers, I should add,
Right.
every bump, cobblestone, and vibration from the road traveled straight up the rigid steering column and directly into the driver's hands. It caused massive fatigue on long drives.
Your hands must have been numb.
Exactly. The banjo wheel solved this by replacing solid cast iron spokes with groups of thin wire spokes.
Which looked exactly like the strings of a banjo, hence the name. So let me guess the mechanism here. If you don't have power steering, you're wrestling a heavy metal box. By making the spokes out of thin piano wire, they act as a literal shock absorber.
Exactly. Each spoke was made of 4 or 5 individual metal wires running parallel to each other. These wires acted as a physical buffer, a sort of literal suspension system for the driver's hands.
That's so smart.
When the front tires hit a rut, the wires would flex and absorb the high-frequency road vibrations before they could reach the driver's palms.
That is such an elegant, purely mechanical solution to a comfort problem. And speaking of driver comfort, we have to mention the 1961 Ford Thunderbird's swing-away steering wheel.
Oh, that's a classic.
Because cars in the early 60s were getting incredibly low, wide, and featured these massive wraparound windshields, getting your legs under a huge steering wheel was becoming physically difficult for the average buyer.
It was a tight squeeze.
So Ford made it so when you put the car in park, the entire steering column would literally unlatch and swing 9 inches to the right. It cleared the way so you could just slide gracefully out of the seat.
It was the absolute height of luxury at the time, though, as you can imagine, having a steering column that unlatched posed its own safety issues.
I would imagine, yeah.
It eventually had to evolve into the more standard tilt-away wheel by 1967 to meet those updated, stricter federal safety standards we talked about earlier.
Okay, so by the late 60s and 70s, the steering wheel is finally relatively safe. The column collapses, you can tilt it, you can telescope it to fit your body.
Exactly.
And once automakers realized they had this safe, adjustable piece of prime real estate positioned right in front of the driver, they realized something else. The driver's hands were just resting there. It was time to give their fingers something to do.
Yes. This is the birth of the steering wheel as the command center.
Right. The first addition was obvious. The electric horn. Early cars had a squeeze bulb on the outside, but eventually they put a button on the hub, or on the spokes.
A huge convenience.
And some automakers even created the rim blow wheel. I love the logic behind this one.
Yeah.
The switch was integrated right into the inner rubber rim of the wheel itself.
Oh, yeah.
You didn't even have to move your hand to the center hub. You just squeezed the wheel hard anywhere on the inner ring, and it honked.
Which is actually a fantastic safety feature. Moving your hand off the rim to hit a center horn pad takes a fraction of a second. But at 60 miles per hour, a fraction of a second covers a lot of distance.
Right, absolutely.
The rim blow allowed for an instantaneous reaction. But, of course, the industry didn't stop at horns. In 1966, that same innovative Ford Thunderbird offered highway pilot speed control.
They put buttons on the wheel.
They put physical rocker switches right on the steering wheel pad to operate the cruise control.
And according to the source material, that specific Thunderbird cruise control had a truly wild feature. It had a retard button on the wheel.
Oh, right.
If you held it down, the car wouldn't just coast to slow down. It would actually tap into the physical braking system, lightly apply the brakes, and illuminate the stop lamps in the back. You're braking the car right from the steering wheel.
It was the beginning of putting total vehicle control at the fingertips. And it just snowballed from there.
Did it ever?
By 1988, Pontiac models, like the Trans Am, were offering steering wheels loaded with 12 different buttons just to control the audio system.
12.
And then the 90s hit, and suddenly you have navigation buttons, cell phone controls, voice command triggers, little scroll wheels.
So what does this all mean? How on earth do you wire 12 complex electronic buttons on a piece of hardware that has to spin 900 degrees in either direction without twisting all those wires until they literally snap?
That is one of the great unsung heroes of automotive engineering. It's an invention called a clock spring.
A clock spring?
Yeah, it sits right behind the steering wheel. Instead of normal wires, it uses a flat, spiraled ribbon cable coiled up inside a plastic housing, very much like the mainspring in an old mechanical clock. Oh, that makes so much sense.
Right. When you turn the wheel to the left, the ribbon winds tighter. When you turn to the right, it unwinds. It allows for continuous electrical connection to all those buttons in the airbag without ever tangling.
That is genius. But, we have to address the elephant in the cabin here. We constantly complain about the dangers of distracted driving, yet automakers have essentially mounted a hyper-complex smart device inches from our thumbs. Are we turning everyday drivers into overwhelmed, distracted airline pilots?
If we connect this to the bigger picture, the steering wheel perfectly maps our entire evolution of human-machine interaction.
How so?
We moved from purely mechanical control, the tiller, to mechanical assistance with the banjo wheel, to hydraulic power steering, and now to full electronic interfacing.
Right.
The stated goal of all these buttons is to keep the driver's hands on the wheel and their eyes on the road, rather than reaching for the dashboard. But you're right, there is a very fine line between convenience and cognitive overload. And there's a physical toll, too. The Wikipedia article explicitly warns about the ergonomics of managing all these buttons while trying to steer.
Yes, the constant repetitive motion of steering requires strategic movement. The golden rule of ergonomics laid out in the source is that your wrists should not be bent.
They need to be straight.
They must be kept straight to avoid overexertion of your tendons and to prevent compression of the delicate nerves and blood vessels in your arms.
So keep your wrists perfectly straight when you're working the volume controls on your 12-button Squircle.
Exactly. And while we're giving practical advice pulled straight from the source material, I have to address a cardinal sin of driving mentioned in the text. It's called dry steering.
Oh, dry steering, the quickest way to make a mechanic cringe.
It really is. Dry steering is when you forcefully turn the steering wheel while the vehicle is completely stationary. A lot of people do it when they are trying to inch into a tight parallel parking spot.
Guilty.
If you are listening to this and you do that, stop immediately.
Let's explain the exact mechanism of why that is so catastrophic for the car.
Well, think about the physics involved. You have a vehicle that likely weighs around 4,000 pounds. The entire weight of the front engine is pressing down on two patches of rubber, compressing that rubber into the abrasive asphalt.
Okay, tons of pressure.
When the car is rolling, even slightly, the tires naturally pivot. But when the car is dead still, the static friction between the tires and the pavement is immense.
So when you just crank the wheel,
When you grab the wheel and force those tires to turn, you are forcing your car's steering rack, the tie rods, and the high-pressure hydraulic power steering pump to violently fight thousands of pounds of static friction.
oh man, that sounds expensive.
It puts massive, unnecessary strain on all those metal joints, and it physically scrubs the tread right off your tires. Always let the car roll even just a fraction of an inch while you turn the wheel. Breaking that static friction will save you a very expensive repair bill.
Consider yourselves warned. No more dry steering. Man, what a journey this has been today.
It's a lot to cover.
We started with early motorists literally trying to steer their motorized carriages with wooden boat tillers. We survived the terrifying era of rigid dashboard spears aimed at our chests. We marveled at the brilliant wire-spoke banjo wheels acting as hand suspension. And we've arrived at the modern era of the 12-button Squircle Command Center, complete with winding clock springs.
It really makes you wonder what the next century holds for this interface. We've gone from mechanical to hydraulic to electronic.
Well, I know you found something buried in the outer edges of the source material about exactly that. What is the future of the wheel?
I want to leave everyone with this final forward-looking thought. The Wikipedia article notes a recent patent applied for by General Motors. It's for a modular steering control system.
Modular. Like you can swap pieces out.
Kind of. This isn't just a wheel with new touchscreen buttons. It is a device that can physically change its shape.
Wait, what?
Yeah, it can transform from a traditional circle for highway cruising into a rectangular yoke depending on the driving situation or the driver's preference.
That's amazing.
But take that shape-shifting concept and combine it with the steer-by-wire technology we discussed earlier, where electrical systems are entirely replacing physical steering columns, and it raises a fascinating possibility.
I'm listening.
Will the steering wheel of the future even be permanently attached to your car? Or will it just be a highly personalized, shape-shifting smart device that you carry with you, plug into the dashboard, and use to interface with whatever autonomous or semi-autonomous vehicle you happen to step into?
A plug-and-play, bring-your-own steering wheel. That completely breaks my brain, but given everything we've just unpacked about packaging constraints and electronic interfaces, it makes total sense.
It really does.
We want to thank you for joining us on this deep dive. The next time you sit down, close the door and reach out your hands to grab that seemingly mundane ring of leather or plastic. Take a second to actually look at it.
Notice the incredible history, the trial and error, and the brilliant engineering resting right there at your fingertips.
It's never just a wheel. It's a century of survival and innovation. Thanks for listening. We'll catch you on the next deep dive.